Now I would like to start with new chapter, that is binomial theorem. Actually, mathematician Pascal gave the concept to explain the expansion of the binomial terms. That's why there was one appropriation, there was one triangle that was made with some rule and named as the Pascal's triangle. The Pascal's triangle is useful for the binomial expansions. Suppose I have a and x, two unlike terms. They may be separated by a plus sign or minus sign. Then how the expansions of a plus x, if its power is some integer, are given. It is like this. If you have written a plus x by means 2, that is binomial two unlike terms. If I put smallest integer 0, I have received its answer is 1. Any number other than 0, that's base. To the power 0 is 1. So a plus x to the power 0, answer is 1. So one thing is there, that if powers are 0 in the expansion, the number of terms are 1. If I say a plus x to the power 1, a plus x to the power 1 gives us a plus x as it is. So power is 1, and in the expansion we have how many terms? 2 terms. It is something to be noticed that if I write a plus x to the power 2, its expansion is a square plus 2ax plus x square. Or this can also be written as x square plus 2ax plus a square. X square and a square are swapped. They are separated by plus sign. So value in both the situations is same. So what is to be noticed? If binomial having power 2, in the expansion the number of terms is 3.